We're live after, I don't know, 6 or 7 tries for me to get on to do the live stream. I don't know why it was not letting me do that. There was something going on with YouTube. It was not happy with my attempts to log on. It kept booting me off. Didn't like my attitude, I guess. Uh, that was YouTube's birthday present to me, unfortunately. But what I want to talk about today is if you look at the thumbnail, you'll see that that's me being crazy as always, which I like doing. Standing by two different intake manifolds. One of them is the tune port manifold. In my opinion, maybe one of the best manifolds that Chevrolet ever offered. Not necessarily because it had the broadest, power curve or made lots of peak power, whatever. I think it just looked cool. And what it did was make awesome torque production. So the question is, and then the other intake manifold that I'm standing by is a dual plane carburetor intake. The go-to thing for it has been for decades, basically, for a small block Chevy. Whenever somebody tells me about a combination, I'm sure 9 times out of 10 of a small block Chevy, and they're like, hey, I've got a carbureted deal. We're doing this and this and this. I'm like, is it a street car? Yes. Well, then put a dual plane on it. I know a single plane, might want to rev, and if you want to do that, you can go that route. But most guys, if you're driving the thing around, you'll be much happier with a dual plane manifold. And that's where the tune port thing kind of excels. And that's it, like low speed torque production. So when you stomp on the gas, if you want something that'll spin the tires, that thing will do it. That thing will produce like mega torque. So it's just a fun deal. But the question is, let's say that you have an intake manifold like the tune port manifold, definitely designed for low speed power, very long runners, small diameter. Everything about it is designed for torque production. They have fairly mild camshafts in those to go along with that. And let's face it, kind of limited head flow. Although the L98 heads, once they introduced the aluminum versions, were, a big change for the small block Chevy guys. We finally had factory aluminum heads, which were good, which meant not so much even for the guys buying expensive Corvettes or brand new Camaros that might have aluminum heads on them. But for the aftermarket, it meant a lot because now there was an abundance because Chevrolet made them available through, Chevrolet Performance, GM Performance parts made them available. And so that the aftermarket all of a sudden had lots of cylinder heads. Not only that, in that case, for small block Chevys, as they went through in the small block Chevy this time period, they went through all of these smog heads, which had fairly big chambers. The Corvette heads had very small chambers. So you could literally just take one off and put an aluminum head on that was better than an 882 head or the smog heads of the period. And not only would you probably get more flow, it's aluminum, it's less weight, less susceptible to detonation, and you'd increase the static compression. So it's a good gain for back in the day. But we'll get back on topic. So the question is, you have an intake manifold like a tune port manifold that's designed for long runners. I hear guys all the time, and particularly back in the day with that intake manifold, and even today, well, Richard, why wouldn't you just, run either turbo with a rising boost curve or a centrifugal blower? Then you can have all that torque and all the top end. And I'm like, okay, well, I understand that. And we've done that many times. Back in the day, we ran tune port motors because Vortec and everybody had, and ProCharger and Paxton and everybody had blower kits for those, and a centrifugal blower on there obviously helped. The torque of the tune port worked well, and then you could, because you had a rising boost curve, it would basically extend the effective RPM range of it. But the thing is, it didn't fundamentally change the design of the intake manifold. So all you're doing was artificially improving it by having a rising boost curve. But even with that, there's a limit to how much even a rising boost curve can fix the problem of that intake manifold. So what guys want is, they see, for instance, if we do an intake manifold test, like the comparison I'm showing in the thumbnail, a tune port manifold versus a dual plane intake manifold, the dual plane is just better. It doesn't probably make quite as much torque as the down low as the tune port does, but it makes a lot more power. It's 30 or 40 horsepower better. So what they want is a manifold that gives them both of those and then plus boost. And just doing the boost thing to a manifold that's designed to have reflected waves in a given RPM range, you're just not going to be able to do that. I mean, you can make it better, but what they want versus what they get is kind of a different thing. And we see this again, like with 4-pattern camshafts. So that you're taking a single plane intake manifold, which in most cases, a single plane intake manifold, because it's designed to have the a centrally mounted carburetor in the intake manifold. You have the runners on the outer side have to take a longer distance to get to the outer cylinders of the cylinder head, the outer ports, and then the ones that are close to the carburetor are shorter. So you basically have 4 longs and 4 shorts. And so the thing is, well, if we take a camshaft and make a camshaft and change the lift and duration of the camshaft on the 4 shorts versus the 4 longs, we can now tune the intake manifold with the camshaft. The problem is, yes and no. Again, if we took a look at just the camshaft, if we had a change in duration of 4, 6, or 8 degrees or whatever, it shifts the power curve a little bit. What happens with the intake manifold is the intake manifold for the runners, assuming that those 4 are identical, which is probably not the case, and assuming that the 4 outers are identical, which is probably not the case. But if they were, you just have them wanting to produce power in that cylinder in a different RPM range. The other thing that happens on the single plane intake manifold, especially carbureted, but we would see this fuel injected in unless you did individual cylinder tuning. You would also see that not only are they producing different relative power curves as we go through the RPM range, but they're also producing different air fuel ratio curves through the RPM range, because a signal from the carburetor from that cylinder is different than it is from another cylinder. So the amount of draw that it has and the amount of power that it's producing is different. And so the air fuel in that cylinder is also different. So the cure for that is really not, and the cam timing doesn't cure that. Again, what you want versus what it's doing and what it was, you're getting somewhere better than it was possibly, but not curing the problem. The cure to the problem is making all the runner lengths the same, making for instance, a tunnel ram intake manifold, or these long runner cross ram EFI style intake manifolds. I've been saying for years that a fast style manifold for a small block Chevy or a small block Ford would probably be easier, because it's not a Siamese port arrangement, which might not lend itself as well to packaging. But if you had that style manifold, that's, in my opinion, that's one of the reasons that the LS motor makes so much better average power than a small block Chevy does, of kind of equal modifications. That manifold is very, very good. Obviously, the factory heads, if you compared it factory to factory, a factory LS head is way better than a factory Gen 2 or small block Chevy head. They're just bad. They just flow a lot more, especially the case in some of the better heads like the LS3 stuff. It's not even close. It might be a difference of 100 CFM. So it's quite a bit. But again, can we cure that? And it's the same thing. Well, what if I get the question all the time about intake manifolds too. Like if I run the short runner manifold, guys want to run the fabricated sniper style short runner intake manifold and on an LS. I'm like, well, if you want to do that because you think it looks good, I understand that. I get that. A truck manifold looks terrible. In fact, most of the factory LS manifolds look terrible. And a polished aluminum one looks a lot better. It's sexier under the hood. You pop the hood, they're like, oh yeah, that looks really good. And so the comments are usually, well, I'm running boost, so it doesn't matter. Well, it does matter. In fact, it might matter. An argument could be made that it matters even more under boost, because what you've done is hurt a bunch of the low speed power. So in addition to hurting the low speed power, if you had an NA motor, now that it's boosted, you've also hurt boost response. So you've taken a double hit down there. But the question is, if I do that, if I run this manifold and it loses low speed power, can't I just run a smaller camshaft and pick up all that low speed power and then have a top end? I'm like, well, no, because if you would have run the bigger camshaft, you would have also had more top end, and the bigger camshaft would have sacrificed low speed power. So again, you have to pick the combination. You have to pick the things that work together to get the best of the curve that you have. And again, you can help things, but you're not going to change the fundamentals of one part with something else. It's really difficult to do. The nice thing is, and we see this on factory stuff, but I think about how much research and development went into the factory stuff, like a factory Gen 5 VVT motor. You look at that, you look at the test that I did on an L83 versus an LM7 or even the L33, any of these versions of that. If you look at those two and compare them, a VVT cam with direct injection and higher compression and I don't know that I would argue that the L83 intake manifold necessarily is a whole bunch better than a Trailblazer SS intake manifold or the truck manifold. Maybe it'd be hard to quantify that in any kind of test since they're on different engine applications. But the Gen 5 is definitely has a lot going for it, and it's definitely better. And one of the things it has is that variable cam timing. But when you combine that with the higher compression and the better head flow and stuff, you get a combination that does very well over a broad power curve. So it's not just better like at the peak. So we see that when GM went from the tune port to the LT1, they made a radical change in their intake manifold design. So they went from a really long runner, super torquey kind of thing to a short runner, which definitely hurt. And I've done back-to-back tests on a LT1 style versus a tune port style. We did that on the little L99 4.3 liter. And the guys from TPIS, Jim over there, helped with an intake manifold that allowed us to run the tune port on that LT1 style head. And when you compare those two directly, there's really no comparison. The tune port manifold is much better down low than the short runner is, and that's not surprising. That's just runner length. So they sacrificed low speed power when they went to the LT1, but they picked up a ton. I mean, we picked up almost 300 horsepower in the Corvette stuff. So we went from 245 or so up to 300. So it was a big jump and a big gain in performance. If you gear it and stuff, it's going to work well. But you did have to sacrifice one thing for the other, and that's at an OEM level. And those guys, have all of the development, the brain trust and power and finances to try to make it work. And still, there are fundamental things that happen with these parts that you choose, and that's a really good example. Now, the other question is, well, what if I take the LT1 intake manifold or that style and add boost to it? You get the same thing. You just multiply the curve by whatever's there originally. So I'm going to go ahead and put a poll up today. Very simple. Does boost cure everything? Let's go for that 100%. Okay, we'll scroll back and see what you guys got going on. Yeah, I was struggling trying to get online here. I was online. I was on the line, but every time I tried to load this thing, it kept showing me that there was a problem. How's everyone on this beautiful first Monday of the week? We are all doing good. Turbo Flapper decided I'm putting a V10 Magnum 671 charge on an Audi W12 car. Oh, that's a lot going on. I got an email or a message from somebody that has a V10 Triton with a Kenny Bell on it. I didn't even know that Kenny Bell did that, or maybe they did that. I'm like, well, that's a big plus. That's big points for you because it's a V10, and not only that, it's a boosted V10, which is very, very cool. Thanks for all the happy birthday, guys. Bam, bam, bam. How much horsepower and torque is gained changing from a 6.0 to a 6.2? If everything else is the same, I'm going from an iron block to an aluminum, and I need a new short block. Well, if we go to our handy dandy calculator, let's say that we were making, let's pick a number. Let's pick 500 horsepower divided by 6.0 equals 83.33 horsepower per liter. We multiply that by 6.2. You're going to pick up 16 or 17 horsepower if the specific output stayed the same. There's no guarantee that it will. Here are some things that happen. One, you have instances where you could pick up power, and you would pick up power from things like compression, because if you went to a larger displacement motor and the piston design and everything stayed the same, from the increasing in displacement, you're going to pick up static compression. So you could theoretically improve the specific output based on the compression. The other thing that happens is with a bigger bore, you may improve head flow a little bit. So now, again, you may pick up power relative to the specific output. The other thing that happens on the negative side is as you go up in displacement, it's actually harder to maintain the same specific output. with the things that you were using. Let's say that you used a stock cam and stock heads and stock intake manifold. If any of those are in any way restrictive, particularly the camshaft in this case, because displacement tends to tame the camshaft. So if any of those are restrictive with the larger displacement, your specific output will not be maintained, and you might actually, you're definitely going to pick up power down low. That's a given. But what happens oftentimes is you'll see power gains through most of the curve, and then the amount that you get at the top could be less. I hope that helps. I have a Lingenfelter Super Ram, tune port setup, large plenum, shorter tubes. Yeah, I have tests up on the Super Ram. We've run that a whole bunch. I had an old 406 that we had a Vortec and a Powerdyne on way back in the day, and that's a good manifold. It shows what it does. It loses power down low compared to the long run or tune port and picks it up at the top. Surprising that no answer to the poll isn't. I know. Does Boost care everything? No, it doesn't, I guess. I don't know who would say that. That's just like crazy talk. That's just crazy talk. It's not in the discussion we were having about the tune port manifold and the centrifugal blower. You can also do that with a turbo, because especially if you have a boost controller and you increase boost relative to engine speed, you can have a rising boost curve essentially, and you can kind of improve that. And in fact, in the video that I'll be putting up for too long here with Jimmy from HP on the NSX, that's exactly what he did. Is he put a rising curve in the NSX motor, one, so that they didn't where they were launching it, it helped them not break things, just like we do with the Big Bang motor, to not have a really big torque number. And on this thing, the torque curve on these VTEC motors is just flat and goes for like 2,000 RPM, where it's making the same torque, which is kind of awesome. But then a rising curve later, we'll find out in the video, because they were extending the RPM range of the motor beyond where the thing was normally making peak power, so that they didn't have to have a 3/4 shift like right near the end of the run. So they could just run more RPM out, and the thing ET'd in mile an hour better doing that than it would if they went to the shift in fourth. If you have too many rods and or too many pistons, boost can help with that. We did cure our lackluster performance in our 454, which is only running good on probably 3 or 4 of the cylinders. We did cure that with boost, and it worked, and it lasted for long road trips, like 6,000 or 7,000 miles. Building a stroker LS418, will ported 799 heads work? Yes, they will. Properly ported 799 heads, if you look at the stuff that we did from the guys at Total Engine Airflow and others, those heads ported correctly can easily flow 310, 320 probably. So that's enough to support a lot of power on a 418. If you want to get an idea, take a look at the 408 video that I did. It was like 625 or something. I think that one had Airflow Research heads on it, but those heads will all support that kind of power level. You have to give it enough flow. And the nice thing about a heavily ported cathedral port head is it will have good low speed power and top end power. It'll have all the things that we were just talking about. So boost doesn't cure everything. Maybe we need to have a different poll, right? Bam, bam, bam. 12 thumbs up. We're only at like 25%. Come on, guys. Step up your game. So we're going to do something today. We are going to, everybody get your answer on the poll, because I'm going to end the poll in 2 minutes. And then we're going to put up another poll. We're going to have a double poll day. A little poll on poll action. Boost costs too much. Boost costs too much, and I would agree with that initially. But boost costs a lot less than trying to make the same power NA, which you can't do. I mean, ultimately, you can't make NA power the way that you can with boost, because then you could just take whatever NA power and you add boost, and then it's more. But the comparison that I get all the time, and I'm glad you brought that up, is that guys want to make, for whatever reason, probably because guys like me put these videos up where, oh, I made 500 horsepower with a 5.3. Yeah, yeah, you did, but you had to look how much money you had to spend. You had to have, the stock bottom end. You have to have really good cylinder heads and a really good intake manifold and a pretty good sized camshaft, and then they want that. They see that that's possible. Wow, but I want it with my stock converter. I want it as a daily driver. Well, good luck with that, because that's not a daily driver cam. You can, like, if I had a stick car and I wanted a zoomy around car that had a cami idle, that combination would work, especially with a fast manifold. It's got plenty of torque and it would work well. Put gear in it and it would be all fine. But it's not something you want to put in your daily driver truck. Like I'd never have a motor like that in my Silverado. It would just be terrible. The thing is, as much as that costs, if you just put a cheap turbo and a pump and injectors and intercooler on it, you would have way more power and way more torque, and it would cost less money. Because probably for the cost of a set of those cylinder heads, like the Trickflow 205 heads, you could put together a decent turbo setup. And, because you're going to have to, let's face it, if you put that NA combination in there, you're also going to have pump and injectors. The injectors may not be as big, although I would make them that big if I were doing it, because you're going to have it tuned anyways. So I would put 80s or something in there anyways. And you're going to have to buy pump and injectors for both, so that there's no trade-off there. So then you're just looking at kind of the hard parts. And the cool thing about a stock 5.3 with a stock cam and all that stuff, and you put a turbo on it, it's going to idle nice, it's going to drive nice, and it's going to be very torquey, and it's going to have lots of power. It'd be kind of a fun deal. So we got a few more votes in, so we will end our poll there, and I'm going to put another one up. Michael, you voted yes. Wow. Boost does put a smile on your face. And once you go boosting, you never go back. I've got an LM7 from a buddy, 200,000 miles, plan on new everything. Is there any benefit, material, performance, friction coefficient that would be worth re-sleeving a block? The only reason that we would re-sleeve a block is if you want to run lots of stroke length in it, because then you put sleeves in it that are longer. So if you're running a stroker, then you don't pull the piston out of the bottom of the bore. Somebody sent me a link to a video of somebody making a 430 something inch motor or whatever out of a stock block, and I'm like, that's fantastic. First of all, so you guys know, if you send me something on Instagram or Facebook or whatever it is, don't ever just send me a link, because I'm just going to delete whatever you sent. Send me an explanation of why you're sending something. Go to the trouble of telling me what you're sending me and why you're sending it to me. Otherwise, I'm not going to open it, because I get lots of weird stuff. So I'm not going to do that. And if you said, I think that this is cool, or I thought you said this couldn't be done, or whatever your thing is, just tell me what's going on. Otherwise I don't open it. And on that particular one, it is possible to put a 4/100 stroke in there and bore the thing out, but it's a terrible idea. Even though you can make it and it will spin over and it will run, it's not a good idea. A 4/100 stroke on a stock sleeve length is not good. That's why people sleeve them, not from a material standpoint or whatever. I don't know what you're trying to do, but if you're just rebuilding an LM7, you should just hone it and put it back together, and it will run just fine. If you're adding boost to it, again, I would just put it together with a cam in it and run it. Otherwise, I don't really know what you're doing. But if you explained, we could give you maybe a little bit more insight. Boost does not solve detonation. It does not. We also have Big Bang uploads, but what conservative numbers do you feel are safe for the Gen 3 5.3 stock bottom end with just ring gap for a turbo street car on E85? Well, E85 and 93 are going to be dramatically different. I'm thinking 4 or 5 degrees difference probably. I don't do a lot of stuff on 93, but if you look at Matt's stuff over at Sloppy, his rule is 14 degrees and 14 pounds of boost is kind of the thing. So low to mid teens and probably less at the torque peak on pump gas. And then you can get away with probably 18 or 20 on E85, depending on the boost number. What oil bypass plugs did you put in the Gen 6 big block? I remember doing it on the, I don't actually remember doing it on the Gen 6 big block, which I should have, but I remember doing it on the 8.1. Lunchtime. I know all about trade-offs for low RPM versus upper RPM. Is there any instances where you find a cam to make a broader power band and make more under the curve? I don't know what people mean by under the curve. When I show you the whole curve, there's nothing underneath it. I don't know what that means. I don't know what people's definition of what that means. The term that people should be using is average torque production or average power production, because that's a better thing. I don't know if when they say area under the curve, do you mean before the torque peak or after the torque peak, or what is the definition of that? There are camshafts that work well in a given RPM range. So if you take a really good example of that is take a look at the video of the Truck Norris cam versus like the sloppy stage 2 cam. So you see that they both produce some kind of torque curve, and that one of them starts getting better later than the other, and then makes more peak power because if it has a similar peak torque number and it does it at a higher engine speed, it's going to make more power. But it's less down low. So you're not going to have a camshaft that will combine both of those unless you have variable cam. And even with variable cam, unless you have valve reliefs that would allow you to have variable cam of that kind of magnitude where we have those kinds of duration numbers, because you need available piston to valve clearance. Not so much for wide open throttle stuff, which was what we were running, but for driving around stuff. So unless you're able to swing the cam or have multiple cam profiles like VTEC, which is why it's awesome, then that's very difficult to do. But the thing is, people wanting more than what you have, like if you put the torque curve up of a Truck Norris cam, or now the Chupacabra or the Summit or the Cam Motion one, because we see that they seem to be comparable. If you put that kind of torque curve up and then you add a turbo to that, there's probably nothing that you put the right size turbo on it for whatever kind of power level you're trying to get. You're not going to want for anything. You're probably more likely than not going to want for traction, I would guess. Let's see. I'm looking for 1,500 wheel horsepower on boost. Then yeah, you're going to need something that's going to be a sleeve block's probably not a bad idea. What kind of horsepower numbers can be expected? I mean, look at the Big Bang thing. You just make a motor that makes, like on a 6-liter, that's really easy and you can do it at fairly low boost, because it's pretty easy to make a 6-liter NA that makes over 500 horsepower, 550, 560. And then you don't have to run nearly as much boost to do that. On a 5.3, it's harder, but it still can be done. You just have to add a lot of boost to make that happen. But if you make a 500 horsepower NA 5.3, which there's videos up that show you how to do that. In fact, the Big Bang one did exactly that. Then you're looking at, 2 bar of boost to make that happen. What kind of horsepower numbers can be expected from an LQ4 with a Truck Norris cam, 10-to-1 compression, and all? I don't know what you mean by all the right ingredients. What else is there? You have intake manifold and headers on it. I can give you a rough idea of what we did if it has a stock head on it. BTR, where's the cam test that I did? So if we take a look at, get a rough idea of something less like on a stock. This was on an LY6 that had rec port heads on it. It was 494 horsepower with a stage 2 cam, which is something you're going to be near there with the truck Norris cam. So that should give you a good idea. And I wouldn't, Hensley, I wouldn't bore there's no need for you to bore the motor out. You can make all of the, I would rather have, especially if you're going for 1500 horsepower, I would rather have the integrity of the sleeve and the block than I would have extra displacement, unless you're going to a 6-liter block, because you don't need that. The turbos will give you the power that you need. There's lots of guys making 1500 horsepower. Well, there's guys making 1500 horsepower with a 5.3. It's not. It's just lots of boost. I don't want to throw my phone number out there for the interweb bots to have a field day with. It's a good idea. Has anyone done extensive testing on what would make the most mile per gallon in a half-ton type tow vehicle on a carb? I only ask because some drag vehicles get the same mile per gallon as my truck. Are they doing it with EFI? If they're doing it with EFI and they can run them lean, then that can obviously help. I don't know about it on a carburetor. The thing that I would recommend is if you're trying to get good fuel mileage, I really kind of want to try a feedback carburetor, so we can run it leaner, like 15-1 or leaner under cruise. But essentially you're fuel injecting it with a carburetor. Port all oil passages and port match. All right. Talking about the little plugs that where the oil filter goes. Yeah, we did plug those. I don't know what you mean by 10 pounds. Are you talking about how tight they are? Intake manifold was 36 degrees Fahrenheit with water meth was 102 without. Are you just measuring the temperature, the outside temperature of the intake manifold? Because that really doesn't tell you. I mean, it gives you an idea that it's colder, but that really doesn't tell you what the charge temperature is, unless what you're giving me is the actual inlet air temperature inside. I asked Brule on the video where they dyno the Super Ram what the brake specific fuel consumption numbers did when that torque mountain happened, and he never responded. Can you see those numbers when you're at Westech? I don't know which one you're talking about. Are you talking about the Skyram one? The really tall one? And they won't have brake specific numbers on those because it's a fuel injected motor. And the way that their fueling system gets run, the brake specific number is not going to be accurate. Scott A, I went to 3091. Oh, I can take a look and see what's going on here. So we're getting a rundown now. Texas is in the house. With limited inputs and outputs of the Holley HP, which would you choose for a turbo street car? I would choose the Holley just because I know how to tune it. That would make life easier for me. It'd be easier to run pump gas on a 408 stroke Cleveland with 9-1 or 10-1 with 8 pounds of boost with an EFI and like a 4-hole throttle body thing is what you're talking about. It would be easier with 9-1 because you're gonna make your detonation threshold window much bigger. And I'm hoping that you have aluminum heads on that. Nova, I don't know what you mean by a 30-pound valve. I don't. Is that the spring pressure release or something like that? I'd have to go back and look. I did put plugs in the 8.1. I'll go back and look at the video and see, because I think in the video I showed where we put them. Yeah, there's no brake specific number for the high ram test or for the sky ram test. It did make a lot of torque though. Richard, I'd like to see you do a new set of tests. I run my turbo 6-liter without a wastegate, but have full boost control using a drive-by-wire throttle body. Okay, so if you're controlling the boost and we're controlling the boost with a wastegate, I don't see what the difference is. And I don't run drive-by-wire throttle bodies on the dyno, except when we had to run the factory ECU stuff. Willie, my son and I are dropping a 525 GM crate motor. We're doing heads and TSP stage 2 cam. See what fun. Does that 525 horse motor already has an ASA or one of those GM cams in it, right? Alex, so you do have aluminum heads? Okay, good. Maybe a test to compare efficiency of wastegate versus throttle body boost control. So what do you mean by efficiency? I don't understand what you're talking about. We know wastegates can control boost. They can, and if we have a boost controller, they will give us the boost control that we desire if we have enough wastegate. Throttling the inlet side would definitely control boost too. But why do you want one to be better than the other? I don't have an air temperature sensor in the intake. It's the mass flow sensor. Oh, okay. But you're not spraying the water meth before the sensor, right? And are you taking the temperature, like are you shooting a gun at the intake manifold or something? What are those numbers from? It'd be a great test to see if the Skyram did run a really good fuel consumption number when it was in the sweet spot. Yes, but the test was done at wide open throttle. So are you concerned with a brake specific fuel consumption number at wide open throttle, or are you interested in running the motor at or near that particular torque peak and having it good fuel mileage? So it would be a part throttle thing. So which one of those is it? Are the piston wastegates an improvement over the diaphragm? I don't know. I have to ask a wastegate designer to tell me what's going on, because I don't know what you mean by improvement. Is it improvement in flow? Is it improvement in response rate? Is it improvement in control? What are the variables that you're wanting to test there? GM 376 525 6.2 LS3 base crate engine. Yeah, but it's got, if it makes 525, then it has a cam in it, right? A temp gun. Okay, I sprayed the manifold. Yeah. So what the thing that you want to know is what the temperature change is inside. If you see it, if you can measure it and it's cold and you have condensation, a lot of times, sometimes the intake manifold will have condensation on it, then that's a good thing. It was a good thing. It was a good thing. Why do you want one to be better than the other? Is an amazing question to understand most questions on the interweb. Well, I know what the see. I'm not really asking the question. I'm asking the motivation for the question. And I know what the motivation is. And I don't know what his motivation is, but I know what the motivation for most of the things that people ask, or for a lot of the things that people ask on the internet. What's better, a Coyote or an LS? They're not asking that question. What they're asking is, can you show me a test where the Coyote did better, if this is a Coyote guy, where a Coyote did better, so that then I can feel good about the choice that I made about the Coyote, and that therefore I'm better. So what they're wanting is reaffirmation of their choice. And that's not why I do testing. Simpler install without wastegate and bypass tubing, but are there some other offset or downside? I don't know. You probably have more data. Well, you do have more data on it than I do. If you're driving it around and running it around, is it working good? Do you have control over it? And I'm interested in how you do your strategy with boost versus throttle angle, and how you have that managed on the ECU. Turbo Smart electronic wastegate, yeah, they are expensive. 226, 236. I wonder if that's on that GM camshaft. I wonder if that's an Elgin cam. Maybe you could run an 80-pound load at the sweet spot RPM and see how much fuel it was burning, then compare. So we'd have to stabilize the air fuel ratio, right? So it'd have to be an 80-pound load, a fixed RPM, whatever that RPM is, and then at, let's say, an 80-pound load required let's make it 12.5 to 1. And then we'd also have to stabilize the timing too, right? KR, I don't need Richard. I don't need affirmation. I'm a Mopar guy from near birth. That's good. That's how I want people to be. I want people to not be looking for reaffirmation. I want them to be already self-affirmed. I wonder how my 7-year-old tile holds up to newer stuff. Does it do what you want it to do? Is always my question. Is it working? Does it limit boost when you want it to limit boost? And then when you adjust it, does it allow boost to go up? If it does all the things that you want it to do, then I would never think about, I'm exactly the opposite of wanting the newer, greater, whatever thing is. If I have something that's already working, I really don't want to change it. That would show if a tuned manifold like that could greatly improve fuel mileage. I would be curious about that too. I just don't know. I don't know what the result of that would be. I don't know if first of all, I think that if I remember right, I think I have this. I thought that I got that. That was a cathedral port. I don't remember what size motor it was though. I don't remember what they tested that on. Does anybody know about that motor? I have to dig through a lot of stuff to find that, but I have the dyno results from that motor. I remember the RPM being higher than you'd want to cruise at though. Some straight gates are pneumatic and others are electronic, but they're cool and expensive. Yeah. And having the super latest, trickiest wastegates and stuff, it probably becomes more necessary the higher the level of motorsports you're in. If you need it for Le Mans, or you need it for, pro mod motors or those kinds of things, you're gonna be asking things of them that a guy that puts something on the street that just has a reference line going to the bottom of the gate, and maybe you can get really fancy, have one go to the bottom and the top with a little controller, even if it's a manual controller or an electronic controller. And then as you step up and need more and more things, then you want more and more gate. But again, for the vast majority of us, I think that these ones that we have work pretty well. What I do want out of a wastegate is, and sometimes I'm not getting this out of the really cheap stuff, is that I want, if they tell me that, well, first of all, obviously you want the diaphragm not to be damaged and you want it to withstand heat over a long period of time. But the other thing I want is I want the assembly to have the spring in it that it's rated at. If somebody gives me a 7-pound wastegate, it should open at 7 pounds. If it doesn't open, and it should consistently open at 7 pounds, not just at 7 pounds now, and the spring gets all saggy, and then now it's 4 or 5 or 6 or whatever. Those are the minimum things that I would expect from a wastegate. Theory, dual plane intake and skinny tube headers may balance out high RPM cam. Also, short intake runners and fat tube headers may help balance out a very low RPM cam. So that's what we were just talking about earlier. Richard, would cheap max being 3582 be decent for a stock 95 F150? Not looking to make a ton of power, just more than stock. I think that's a little small for a 5.4 or for a 5 liter. Oh, it's a 95. I don't know that I would pick a GT35. I think I would still pick a GT45 for that. Although, I think I ran one of the single 76 millimeters. I don't know how big they actually are. I think that they're less than the, I think that they're smaller than the GT45s are. From CX Racing, one of those turbos seemed to work fairly well on a 5 liter Ford. Yeah, I guess with self-regulating electronics, I guess it's more complicated. Well, and I wouldn't allow it to run in closed loop. I would adjust everything so that it's right. So I would make the airfield exactly the same, especially at a stationary load. That'd be very easy because we could just play with it while it's loaded. So we would, the timing is very simple. You just make the timing be with what you want the timing to be at that RPM and load that load cell. And then we just highlight it all around there so it didn't change. And on the airfield, while it's loaded, you just adjust it and say, hey, look, I want it to be 12.5. And we would make it 12.5 so that it doesn't move ever from 12.5. And then you would have to, I guess, see what the, I don't know how we would measure how much fuel it's using though. So I guess what we would do is run one and optimize it, put it at the airfield we want, put it at the timing we want, put it at the RPM we want, put it at the load that we want, and then put the other one on and then see if there's a change. And if there is, then we could get an idea, I guess. Algorithm throttle plate open full till target boost is approached, then close throttle plate to preset location based on the table. So are you using you have boost tables then in there? That's a cool combination then. Scott, you got some koi? Some new ones? I asked because my 95 with a stock truck cam and intake is done making power at 4,600. I can almost guarantee you it's not done making power at 4,600. It will rev higher than that. If you don't want to rev it higher than that, then you don't have to. Try it. That's the only thing I could say is you could try that GT35 and see what happens. Yeah, turbo sensor, that's a perfect example. The wastegate, I have said 12 psi and was more like 20 psi, the internal wastegate. Yeah, if it's an internal wastegate and you're trying to run lots of power and lots of boost, it's really hard to get an internal wastegate to have a big enough bypass for it to work. It just doesn't flow enough so that what you end up with is a rising curve. Now you can use that to your advantage to have a rising curve, but it's not good not to have control though. And Burns is right. We've also ported some of the ones way back in the day on the turbo SVO turbo Mustangs, the ones that were on those and the T-Birds and the Mercurs. Yeah, raccoons are. My dad had a goldfish in his pond, and he had to put screens and stuff over them because the raccoons were going nuts. Is the ignition cut in the Holley a good free backup for wastegates and boost spikes? Yeah, they have boost cutouts, and then you could do that with our RPM also. Do they make wastegates with an adjustable proportional opening, or are they all or nothing? Well, the way that a wastegate opens, it doesn't jump all the way open. It actually slides open, which is part of the problem with them. When you're running, especially if you're running the boost reference to just the bottom side of the gate, because back pressure can help push that open. So it pushes open a little bit. That's why you get a lazy gate and a lazy boost curve. That's why boost controllers help that hold it closed at the top. But having it slide open, I wonder if that would help the transition, because that way you wouldn't see a drop in the torque curve. What about butterfly style gates? I don't think I've ever tried one. But again, the big picture is having a turbo and having a wastegate that works and having it run 10 pounds. And then with a wastegate controller, if you still have it set at 10 pounds, then you can have it have 10 pounds and then not be lazy at this little part where it's getting up to 10 pounds. It can be better. And then 10 pounds becomes more and more and more. Oh, I never even went to live chat. We're going live. Goes to 11. I can scroll back and see if I've any got any live chats. Electric or using CO2 is a good way to run wastegates at higher boost levels. Yep. And then you have more dynamic range for the gate if you start adding that stuff in. Fuel cut timing or throttle cut for Revlon? Just curious. I like doing fuel cuts as long as the fuel cut is immediate. A lot of guys do timing cuts for traction. And we never had the option of doing throttle cuts because I don't run these with electronic throttles though. If you want to tune it to have a rising curve like a centrifugal and you can control it electronically, that's almost the only way to do that, unless, like I said, unless you have a restrictive wastegate and it does that by design because enough exhaust can't escape. What's the average cost to test an engine on the dyno? It depends. You have to call around. It's different. It's different for carbureted ones. It's different for fuel injected ones. 2 more minutes. Dose. I have to go finish putting up some. I got to put up a light fixture. Do you ever test with closed loop boost controllers? I don't. We have I don't know if that qualifies as a closed loop boost controller. We have a TC1 electronic controller that I've used on the dyno a bunch, and it has a, we have a call out basically for a boost level that we want, and then we obviously have to wiggle around with the duty cycle to make that happen. But once we do that, then once we get that right, then we can adjust the desired boost to what we can, adjust it to whatever boost level that we want within reason of the original spring that we're using. Tim, how many calories should I go for on the bike today? Well, don't stop until you've burned 1,000. That's a long ride or a lot of hills. Thank you all for the birthday wishes. 1 more minute. Tick, tick, tick. Time is ticking away. I obviously have to fix my thumbnail because I'm pretty sure it's upside down. Yep, 21st. I am in my late 20s. Yeah, 1,000 calories on anything is forever. It's very easy to eat 1,000 calories. It's really hard to burn 1,000 calories. People get that realization when you go, like if you go on an elliptical or on a bike or stairs or whatever you're doing, and it's reading the calories, and you're like, man, I've been on here forever. And that was just like one candy bar. It puts it all into perspective. Not that I don't eat candy bars, I do, but you realize how hard it is to burn that off. $1,000 calories is 2 hours of chopping wood. I'd be surprised if 2 hours is doing that, because I remember doing I used to have my wife just take me out in the country and leave me. She'd take me to the farm, and then I would run back. And so we'd do like 8 miles and 10 miles. And then she took me out this one, and I ran back, and I was getting close. I'm like, well, I'm going to keep running until I get to like a half marathon. And it's the only time I've ever done it. And I will never do it again because it was miserable, because I didn't prep for doing a half marathon. I took 1 bottle of water, and I had one thing of like, I don't know, some kind of bar or something that I had with me. I took 1 sip every mile, which is not smart. And I didn't eat the day before correctly and stuff. So, but I went out and did that. And I don't even know if that was 1,000 calories. And I ran for, a couple of, I'm sure that was a couple of hours. Although chopping wood for 2 hours might be more vigorous than what I was doing. Plus, you're getting all lumberjacky. Spent 2 hours on idle tune alone and part throttle, like 3 to 4 hours. It does take a long time to do that part of it. Way more than the 5 or 6 runs that it takes to do wide open throttle. Wide open throttle is really easy. Wow. Hey, it needs here, 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 here. Put that in. Look, wow. Okay, just 1 more trim. Wow. Look, it's good. That's the air fuel. And then we go, okay, it's at 25 degrees. Let's go to 27. Let's go to 29. Let's go to 30. It's not doing anything. Let's go back to 29. Look, it's done. NA stuff is really easy. Boosted takes a little bit more, but not a lot. Especially if we already have an NA one to start with. Then we just take the top 3 lines, double them, put them up top, interpolate. That's going to be really close. Then add 10% everywhere because, it's going to be richer. Yeah, wide open throttle takes nothing at all. That's why I was laughing. People tell me, oh, yeah, I could have tuned more out of that. Silliness. Yeah, good remote tuners probably are hard to find. I don't envy them having to, like, not even being able to be there would be hard. that's got to be a difficult deal. But, you know, I'm glad they're out there. And on that note, it is time to go. I have to get going. I will be back maybe tonight, although we're going out. Celebration, you know, birthday stuff. But I'm going to try to put up another video on the helicoil and fixing the cam retaining plate because I put a lot of work into that. And it turned out to be, it actually worked. All of the bolts secured it, and it worked out well. Thank you guys all for showing up, and I'll probably see you guys tonight. Fingers crossed.